If I asked you what gravity naturally does, you would probably say it pulls things together. We watch apples fall to the ground, we track moons orbiting planets, we see entire galaxies holding together over billions of years. Attraction feels obvious. Every single one of those examples comes from the same kind of place, regions heavily packed with matter. We learned the laws of gravity inside the cosmic equivalent of crowded cities, and then we assumed those local rules defined the entire ocean. Early astronomers looked at the sky and placed the Earth at the absolute center of reality, simply because it was where they stood. We once thought the sun was the center of the universe because it dominated our sky. Time and again, progress has required us to look past our immediate neighborhood to find the actual rules. This diagram illustrates our current blind spot. These glowing dots represent the matter-rich environments we know. They make up roughly 5% of the universe by volume. The remaining 95% is sparse, dark space, completely empty of the structures defining our local experience. We have been letting the crowded, incredibly rare 5% of the universe define the baseline rules for the other 95%. To find the true nature of spacetime, we have to look away from the galaxies and focus on those vast empty regions. As matter thins out on large scales, the universe expands and accelerates, a state known as de Sitter behavior. Standard cosmology assumes spacetime naturally sits still or pulls together, requiring a mysterious external force, labeled dark energy, to push the universe apart. If we remove that added driver, a different picture emerges. Geometric repulsion may simply be the natural baseline of spacetime itself. Late-stage cosmic acceleration is the universe's default state finally re-emerging as matter thins out and stops muffling the baseline. Consider the ground beneath your feet. You are familiar with walking on pavement. Pavement is a local condition built over the ground, separate from the Earth's natural state. Attractive gravity functions as the built-over condition, found specifically where matter is heavily concentrated. Rather than creating gravity from scratch, high densities of matter actively suppress the universe's natural repulsive baseline. Attraction dominates our local experience because we live inside a matter-rich pocket dense enough to crowd out the natural cosmic repulsion beneath it. To test this, we must look into the deep interior of cosmic voids. Voids are the only accessible large-scale environments where matter is sparse enough to stop suppressing that underlying baseline. This creates a logic chain. Deeper voids contain less matter, which leads to less suppression, allowing the repulsive geometry to emerge. These pristine empty spaces serve as the ultimate control group. If this baseline theory is false, this is exactly where the math should fail. We hunt for that baseline using two different probes, like tracking the cosmic microwave background and galaxy shapes, to measure how light bends as it travels through a void. If the repulsive baseline exists, these two probes will react differently to the empty environment, causing their measurements to separate. By tracking this divergence, we calculate a probe ratio. A ratio that drops as we look deeper into the void provides tangible proof of the baseline bleeding through. The predictable fall of an apple and the laws of relativity remain intact as the specific rules governing our dense local environment. The vast, dark regions we once ignored as empty background may hold the most honest map of how spacetime behaves when left alone.